So what we got going on here today is a simulated tray. We have a tray of parts here. We have a VF3 Super Speed. Now this machine is a full-blown production monster. It has 4 chip augers, a chip conveyor. It's got air blast, so we use it to blow the parts off before the robot uses it. It's got probing. It's got a trunnion setup in it now. It's not a 5-axis part right now, but it has that capability. It's got a 95-gallon cooling tank. It's got a filtration system to get the chips out of there. I mean, this thing can run over a weekend, and even if it loses coolant, it can still make, well, I'm sure we've all drilled a hole without coolant. It doesn't work really well. And we got the next-gen control. Now, the next-gen control gave us a few benefits. It introduced a safe cell parameter. So with a safe cell parameter, we can execute an M code with the door open. We basically give it a pulse signal that says, hey, either a cage door is closed and it's going to get that signal, or we're telling it, yes, the robot's in a safe place. You can call the robot to unload and stuff like that. That way we can actuate clamps if we need to, or any other kind of work holding. So we're going to let this robot run a little bit. The first thing it's going to do is pick up a part here. It's going to open the doors and it's going to place it on the vise. Then it's going to machine it and place it on the equator. Now, all this process takes a few minutes, and I don't expect you to sit here and watch it from your seats. So if there was any preliminary questions, I can answer a few questions now. We can run this, and then we're going to take a break. We have to do a computer swap over for the next speaker, because they're Apple people. So we'll see what's going on there. Grab some coffee or some snacks or something like that. But let's give it a go. Nick, go ahead. No, free drive. Free drive is one really handy function of this robot. When we position it around, instead of using a joystick or jog handles, you can position it in free drive. It's got an internal clutch. Go ahead, Nick. So if you're holding the control in your hand, you can move the robot and position it where you need to. It's kind of nice. This one's like as big as I am, so it's like wrestling in a big league. All right. So we'll start the program. You always have to start the program from its very first move. We labeled a waypoint. We basically set a series of waypoints with universal control, and it follows those waypoints. So we're going to go and set it to home yet. So press home.
Hey Bob, how many operations are you doing here? Putting it in, flipping it over?
We're going to put it in, cut the part. The machine says, "Hey robot, I'm ready." The robot comes in, flips the part over. Robot comes out, says, "I'm done." The machine's the back side of the part. Robot says, "Hey, I'm done." Robot comes in, grabs the part, places on the equator, picks up the next part, and starts repeating that process. We added probing inside here to make sure all of our surfaces blend. This robot does have some force control to push it in a vise against the stop. We did kind of both. We don't want to, well, as Brian says, I don't want to throw one out the window.
Bob.
Is that robot at full speed, or do you have it slowed down for demonstration?
This robot is in full speed. It was 1,000. Where's Andy?
It's full speed in safety mode.
It's full speed in safety mode. It can go a little bit faster. You can push it past its full speed, and then you start, it's like a tool. You can go real fast, and then you go really, really fast. But really, really fast, you're going to buy a new end mill. So we can push the robot faster. It just wears the joints out. That gripper on there is a Robotique gripper. You can adjust the position before it goes and grabs. It has force control, so you can, if you have a delicate part, you can adjust how much it squeezes on it. We had the same style gripper here at our last open house, and we held a round part by, we 3D printed a gripper to hold a round part. This one's got a standard finger, which is aluminum with a rubber backing.
How long for integration? From rolling in the robot, setting it up?
Magic question. I can lie to you and tell you it was super duper fast, but it wasn't. It took about 4 days to fully develop the integration of the equator, the universal robot, and the machine. Some of that time was learning experience because we never incorporated all this stuff before, and then developing a sequence that was efficient. In a normal situation, a demo day, we had a lathe back there. It was a simple pickup from one spot, put it in the machine, flip it over, put it back in that one spot. That took us a half a day doing the crate. It was an end signal and open and close the truck. Pretty simple. This one's a little more involved.
So you could do this in half a day?
You could do a simple pick and place in half a day. The control's really simple. It's all conversational programming. It's called polyscope. It's got scan cycles. You go to a waypoint, you store it, move it to the next one, store it, open the gripper. Go ahead, Justin. Does the robot need to be anchored for the ground full speed? Yes. We have the benefit of we're using a base provided by pneumatic engineering that's got wheels that lock it in place. But if it's moving full speed and it hits something, it could move the base. And if it moves the base, all of our waypoints are off. It's highly recommended that you anchor it to the floor, and then it doesn't matter because instead of picking up a part and going over here, you can just whip it as fast as you can to the other side because it's anchored and it's not going to move.
What is the interface between the robot and the Haas control?
The interface between the robot and the Haas control. So we divided some of that in half. The Haas control is in charge of opening the door and calling the robot. We gave the rest of the control to the robot. The robot handles opening and closing a vice and sending a safe cell signal to the machine that says, hey, it's okay to call me with the door.
Bob, weight limits? Weight limits, and what about
this is a UR10. This is the biggest robot Universal Robot makes, and I believe it's 20 pounds? 22. I was close. I knew it was in kilograms, and I was never going to get that. We're actuating the device with inputs and outputs in the Universal Robot. So in our robot program, I say, turn digital signal 1 to high, which turns it on, and then when I want to clamp it, I say, hey, turn that one off and turn close, turn open and off. So, it's an air actuator, pneumatic device, and I'm opening it with solenoid.
Bob, what about the cage? Necessary, not necessary? All the accessories around it, it's all available. You don't have to go buy that at Home Depot, right?
The cage is from a company called 8020. It was provided to us via pneumatic engineering. It's really an erector set for adults. You could build anything and you could dream of in any configuration ever. Now, this is a collaborative robot, so if I were to go in the cage and the robot would hit me, well, I weigh 100 pounds, so it's going to push me out of the way. But probably most of you guys, it's just going to move you a little bit and stop. When it hits 10 pounds of force, it will stop.
Is the program for the robot, is that like a script, a file to be edited manually, or do you have to always program it via the...
Yes. So the question was, is the program for the robot a script, or do we always have to stick with the polyscope conversational? Yes. That conversational generates code in the background with script code. There's information in the manual on how to learn how to write it. It looks close to, I understand G code and macros. I was able to follow it and understand what was going on. Go ahead, Andy.
I will have a small robot, tabletop size, so like at lunchtime
Yeah.
and after that, I can kind of go through and show you some of the collaborative nature and some of the programming questions.
Andy's gonna set up a little robot over there. You guys could jog it around, look at the control. Teach it to scratch your back.
What do you guys mean by collaborative?
Collaborative means, you know what, Mike? I went to a universal robot class. It took me to day 3 before I got enough balls to ask that question. Or guts, I shouldn't say that. I'm just women around, I'm sorry. Collaborative means it can work with you. It's designed to sit next to you, you teach it to do something and work with you. Instead of, oh, that robot is set up just to do one thing. No, you teach it to do what you're gonna do that day in a few minutes, you work with it, and then the next day, you unlock the wheels, you roll it over to where you wanna work, and you work with it over there. I'm sure Craig will have more to say that in a more professional answer. So what it did is it put the part on the equator, came over to the pallet, grabbed another part, loaded the machine, and we're starting that sequence all over. It's measuring a part, and you notice over here, I'm stealing away from Kevin and Marty. So we're following a hole. And inside my program, I have a little macro command that's adding wear offset every once in a while so we can see it changing. Now, in real production life, we would set a barrier, and as soon as it got to like a warning area, it could tell us, hey, a tool's wearing, or it can automatically make a wear adjustment and send it to the control, adjust the tool so our next part is back within nominal spec. I think we're right around break time. We're going to let this run for a little bit. And then we got some, well, there's probably still muffins and bagels and some snacks back there. We need to make a computer changeover, restrooms, through those glass doors to the right or through these glass doors to the left. If you're going to use the front restroom, please be careful. It's a narrow hallway.